Hey guys, and welcome back to SciShy. In this video, we're going to be showing you how to make an Agarose gel as a continuation from our gel electrophoresis video. In this process, we're going to need TAE and Agarose powder, and I'm going to take a quick second to slowly measure out 1 gram of Agarose powder onto the scale, and while I do that, I'm going to talk a bit about Agarose. It's a natural polysaccharide that's derived from seaweed and red algae, and when it's cooled below 45 degrees Celsius, its repeating chains form double helices that allow it to create a 3D structure. Now I'm making 1% Agarose gel, and that's going to have about 100 to 450 nanometer pores. Now that we have our Agarose, I'm going to measure out 100 milliliters of 1 times TAE. TAE is a buffer made up of tris base, acetic acid, and EDTA, and its primary use in molecular biology research is in Agarose electrophoresis by separating out nucleic acids like DNA and RNA. Now I'm guesstimating this measurement using a beaker, and beakers aren't normally used for measuring volumes. If you want to be a bit more accurate, you can use a graduated cylinder instead of a beaker to better measure out your volume. Now, a side effect of that is that I'm going to take a bit of time to make sure I have 100 milliliters of TAE, and while I do that, I'm going to re-explain the ratios. So if I have 1 gram of Agarose in 100 milliliters of TAE, I'll make a 1% gel. And this is likewise, so if I have 100 grams of Agarose in that 100 milliliters of TAE, I would have 100% gel. And the pore sizes are matching, so if I have a 1% gel, the pore size is between 100 to 450 nanometers, while if I have a 2% gel, I would have about 140 nanometer pores, and so they become smaller as you increase that concentration. Now, I've poured in this Agarose and I'm slowly going to stir it with the same tool that I used to measure out that Agarose earlier. Now, it's not exactly going to dissolve because Agarose dissolves at boiling temperatures, but I want it to be thoroughly mixed. Now, I'm going to put it in the microwave for about a minute, and this is going to help us dissolve this Agarose into the TAE. While the Agarose is dissolving, I just want to let you guys know that if you have any questions about the concepts and procedures mentioned in this video or the videos beforehand, you can let us know in the comments below, and I'll answer it in the next video. Okay, so we have our Agarose, and as you can kind of see, it's not fully saturated. And so what I'm going to do now is I'm going to stir it a bit in my hand, and I'm going to put it back in for a minute. This is pretty common. Usually it takes about 2 minutes for this Agarose to fully dissolve in the TAE, and once you're about done, it should be clear. Now, don't do what I just did right here. That flask is extremely hot. Make sure that you wear some type of protection, some type of glove when you're taking it out of the microwave, because again, it's going to be boiling. That's what the Agarose dissolves at, and that's when your TAE will be completely clear, and you shouldn't see any more Agarose powder in the flask. The last step in this process is pouring out the gel. Right now I'm setting up what I'm pouring the TAE Agarose mixture into, and you want to make sure that it's tight and sealed so that no TAE Agarose mixture leaks out of it. When you pour it, you want to make sure that you pour it slowly and make sure that it does not go all the way to the top. And that's because we're going to add a comb to help us make sample wells. As you can see, the comb is connected at the top, but we want distinct sample wells, so make sure that you don't overfill this gel. Now, in about an hour to 45 minutes, we should have a finished gel, and pardon my dancing, but hopefully you can recreate this process when you do your own experiment, and we'll see this gel in our next video. Thanks for watching.